Surprisingly, this assignment, which is what I want to get in the next couple of days, I think we can start doing this by Thursday easy. Because it actually doesn't involve too much more for you. Do you want to know what the graphics engine to do this is? It is Turtle. This is Turtle. Turtle graphics are done with this. This is done with Turtle graphics. All they did is that they've replaced the turtle with the hurricane symbol, and they've updated the background to be the Atlantic Basin. And so the question is, of course, where are you getting the? Yeah. And they set it up so that the latitude-longitude coordinates correspond with the XY coordinates over here, making it so that it seamlessly translates. But otherwise, all the other work is what we would have to do. So how do we figure out what to do? The data is already provided, but by the time you're done with this class, you'll be able to rip the data yourself. And all the data comes from here, and it's stored in what's called a CSV file. Anybody know what a CSV file is?
Something values?
Yep, something. So it stands for comma separated values. Here, let me grab this, copy it. Oh yeah. So let me go ahead and just for clarity, I hate Excel. I really do. So I just copy pasted this in here. Mainly because it's a proprietary format and I can't just open it with a basic text editor and modify it. But if I save this, I can save this as, save it as a desktop, and let's go ahead and save it as a CSV over here. All right. And now, it's telling me, hey, you don't get special features in the CSV file. And I'm like, I don't care. What a CSV has is, let's go ahead and open it up in a text editor. I believe that's what I think we have the degree symbol there. Yeah, just that. So that's just simply the degree symbol, not I'm not rendering. But notice that basically every field is separated by commas, right? So hurricane, and then so it's a tropical storm, no strength, hurricanes, class, a strength of 2. Category 2, that's it. Category 3 hurricane, the pressure, the maximum wind speed, and so on and so forth, right? And a lot of times Excel file, this is a lot of times easier to work with than an Excel file, but the book does go over how to deal with Excel files. Now, before we get into that, we need to be able to work with a few more basic things. Because typically when we deal with files, we're reading stuff, and then we want to basically take we want to read stuff line by line and then transform it into a list. So we still got to figure out more stuff about lists. Dictionaries are useful, and I might as well I can go over them. But I have a couple more. But I have a couple of just basic, easy exercises to make sure we understand lists.
Sorry, I just realized I was naming it sets.
And then the pattern, and we can basically, though, we've got the ability to now jump around the book as needed. So what we really have to do for this next couple of weeks is we're going to learn two things, which is better understanding of how we can deal with lists, okay, and understanding a better understanding of how we can deal with so we're going to learn about lists, dictionaries, and then we're going to learn about how to open files and read files, just pure text files, which we've kind of already gone over and dealt with. So I'm going to go and introduce a problem that we don't have the answer to yet, but I like the problem because it's a very kind of common problem that occurs a lot these days. Also because it's one that if you ever decide to get really into the weeds, it's one that can be parallelized among multiple computers. And I like this problem also because it will bring a lot of different elements together. Okay. So if you remember, I have the complete work, here I have the complete text of Shakespeare, right? Right. And suppose I wanted to figure out what the most common word used in William Shakespeare's text is. Now, this is a bit of a tricky problem because we haven't learned about dictionaries yet, so we don't know that dictionaries are the correct solution for doing this. But we do know a couple of things, which is that we do need to know how to open. We've briefly seen how to open a file, very briefly seen how to open a file, not in the sense that you know how to use it, and also we know how to basically, well, actually we don't know much beyond that. We don't know really how to parse this file or turn it into something. So, but figuring out like the most common thing is a very common problem, as you might imagine. So let me go ahead and boot up idle, and we'll start with a counter. So save as Andrew teaching. Now this is a problem that students can't typically solve until they get to 2168, but Python makes it easy. So yay Python. We're going to go ahead and put it into classroom. And I'll call this will counter for William Shakespeare, and just make sure you have it in the same. In order for this to work, we'll have to be in the same folder as. We'll have to be in the same folder as. Yep. Where's my script? Did not.
Otherwise, you have to name it out.
Yep. Otherwise, you'd have to tell it exactly where it is, and we'll get into that. The chapters really go into this. So, oh, I see. That's why. It just dumped the text in there for some reason. Open, Andrew, classroom. And I don't know if this is the right example to use, but it's a good example, and it's exciting, and I feel like we're at the place where we can diverge on many different paths, and this helps us get there. So that's what's the problem. Awesome. All right, so the first thing we really need to do this is be able to open up our file, okay? And that deals with paths and stuff. So the way you open up files, just a file on your computer, is using the open command, okay? And you just provide the file name. If you're in the same directory, which you should be, you just simply say open and then the file name of whatever you're trying to read. Complete.txt over here is what I'm trying to read. Okay? There's other things we can do with files. Let's see, text. But let's see. If I put W, let's see what happens. Does it let me? I'm not sure why it's not letting me do it. Yeah, let's just do it read. So this will allow us to essentially read a file. Typically, since I provided a second argument here, an R here, which means that I'm telling the computer I'd like to read this file, and that's just it. Just read it. Don't let me change it. All right. And as far as it's concerned, I can, that's essentially it. Now, if I try to print text, I get, we'll go ahead and run it. And running it will confirm that this works. You get something like an IO wrapper, right? Oh, and we had to do something like encoding. We had to also, because this was a weird file, we had to say.
Oh, the character type?
Yeah, we had to say what character type it was. So we just, yep, there we go. So file. So the file was complete.txt R, and then the encoding was equal to, I think we just had to say UTF
180?
8. I just can't remember if there was a dash in there or not. I can always open the other. Let's see. I can open the other example. If I remember what that was. For printing, I believe. Yep, encoding is UTF-8. Okay. And so if I print this, I don't get. This will confirm that it just works. Now, this is just simply it waiting to read line by line. I can store all the text in a single variable if I wanted to. I can say like something like actual. Let's see, list of. I'm going to give you exactly what it is by throwing the text into a list. You can throw anything that's iterable. In other words, anything that you can. So an iterable is anything you can go through kind of line by line or step by step. So like a list is iterable because you can go through that step by step. Range is iterable because that's step by step. And you can throw it into a list and just store it in a variable. But now it just takes up memory, whereas here I was actually reading it one at a time. So if I now say a list of lines, list of lines is equal to, if I say to now print row 3 of that, I get, well, that makes sense because there really wasn't anything there. So let me go ahead and change my, let me go ahead and change this. Begin file. So I'm just going to put begin file over here. So now if I grab list of line 0, it should print out begin file, right? If I were to grab line 1, it's going to grab Project Gutenberg's The Complete Works of William Shakespeare by William, right? And now if I go to 2, Shakespeare, right? There. So it is. Actually, since I'm in the compiler, I think I can do list of. Since I'm in the interpreter and it's running in the interpreter, I can actually play with it here, right? I can. So it's all stored in there, right? So you can store anything in a list. So what we could do is that we can also do something silly like, print out just the first character every line, right? Now I can go through, because I've already stored it in list of lines, I can't really go through it once again. Like, so for line in, I can't go through text anymore since I've already read it all. And here's me just printing the first character of everything. See, it doesn't let me go through it again because I've already gone through it once. If I change this to list of lines, and now I'm printing the first character of every single line of the file. And I can do that because I'm just reading through what I already have stored. So open provides a way to read through it exactly once, right? Because once you're done reading a line, presumably you don't need it anymore. If you needed it again, you should have stored it, right? Is kind of the idea. So here I'm using the stored to run through it. Okay. Now let's go ahead and actually trim this down, maybe to make it a bit more easy. Let's go ahead and just deal with maybe the first 1,000 lines. That seems a bit more reasonable, right? Otherwise, we'll be waiting forever. So let's just get the first 1,000. So that means creating a slice, right? And 1,000, right? So this will go through line 0 through what number? 999. So now this is just the first character of the first 1,000 lines, right? And that should be, that should stop. Yep, okay. Okay. So, and if I instead just print out line instead of character, right, I'm getting all this stuff. Okay. Now my Now so let's go ahead before we get into figuring out the most common words. Let's get into a more interesting thing. How do I figure out what the heck a word is? Right? What do we qualify as a word? Yeah, that's a pretty good definition. Anything separated by white space. And then there's the occasionally, and then we're going to eventually need to trim out these commas, right? But we can leave that. So if we wanted to do more of a word count rather than figuring out the most common word, right? Just actually literally count up how many words there are in the first 1,000 lines of this. That should be fairly straightforward once we figure out what we want to do, right? That's a count is equal to 0, and then do all this, and then print our count out, right? So, and rather than going through it now, since we're going through this line by line, actually this makes it slightly easier because we no longer have to worry about the whole text. We just have to worry about this on a line by line basis. So given a line, how can I think of text, given a single string, because that's what this is, right? Given a string, how can I figure out what is the, how to make a word out of it? So within string, there's a whole lot of functions. So so let's go ahead and look up everything that a string can do. Now, this is something I haven't shown you before, but Python has what we call documentation, which means that basically that you can look up everything that comes with Python and what it can do. It has a basic tutorial, like for if you need to learn Python. And some of these do assume that you already know. It assumes a bit maybe that you know a bit of programming already, but that's fine. The library reference. Keep this under your pillow. This has like all the other stuff that it has. So common string operations. So there's a whole lot of basically functions and stuff. Let's go ahead and I'll use the interpreter for a second. So if I give it so let me go ahead and actually physically import string. You don't need to import string, it's already there, but now I want to be able to play with it. So string dot ASCII letters, right? This contains all the letters that are in ASCII, right? So it has some neat little constants for you that you can always access. But strings also have all these functions that are really useful. And they talk about how to manipulate them, but really we want to get to the functions. Come on, is there a... No. String constants, string formatting. Format examples. These are common string operations. No. String methods. See also string methods. Here we go. So you can capitalize. Return a string with the first character capitalized and the rest lowercase. Center it. So you can center these things. You can change the encoding. You can find a string. Like I can ask, for instance, print line dot find the, right? And this will answer the question of does this line contain the word the? And it's returning where it does. Right? Notice it's shooting out a bunch of numbers. We can also, so that finds you where, that finds where in the string the position of the first the is. So that's kind of nice. But we were looking more for like how can we like maybe deal with something towards getting it split up into word. Its place is title join. That we looked at that. That's a way to get stuff to put strings together. Split returns a list of words in the string using separator as a delimiter string. If Max split is given, at most max splits are done. So returns a list of words in the string using separated as a delimiter. Let's look at the examples. Those are typically way more clarifying. So if I pass in the string 1, 2, 3 over here, okay, and I tell it to split with a comma, it returns a list of strings, 1, 2, and 3. So see how it splits up everything separated by commas? So when we're dealing with the comma-separated values, this is obviously going to be very useful. Yes?
Can you use a Boolean statement in there? So like
Commas and white space. I'm guessing maybe we might be able to. What can you do in there? Can we make it? Can we use regular expressions there? Is the better question, and we'll see. So we're going to right now just keep it simple and separate everything by spaces. Which, if we just simply use the dot split without any arguments, we'll be able to do that. So let's go ahead and print what happens if we take the line. So we're going to take the string called line. So if we do this, words is equal to lines, okay, dot split, we can print out words. The name lines is not defined. Oh, for line. Right, that makes sense. And now, as you can see, it's going by really fast, but we're getting it's getting split up. How careful was I when I took my way, right? So now it's split up into basically anywhere where it saw space, it split it up. Okay, so that's useful. Some of these we have some random 47s in there. Why do we have some random 47s? Oh, because because we're dealing with the sonnets right over here. So it's saying it's sonnet 47. So now if we do that, and we can now say, well, okay, if we split it up into individual words like that, we can now say count plus equals len of words, and that will tell you, and len, remember, tells you how big something is, right? And now we run that, and it says, hey, there were 4896 words in there. Okay, so now how do I get into the idea of like what is the most common word, right? So we're going to be working a lot with strings, dictionaries, and lists for the next couple of for the next bit of class. So let's go. So dictionaries are covered in the next chapter, which is chapter 6, I believe. Sorry, chapter 5 actually. So dictionaries are possibly the most powerful data structure you have at your disposal. And they're essentially an abstraction of lists, and they sound very theoretical when you talk about, like, it uses key value pairs, right, to store stuff. You give it a key, you store a value. So here's an example of a dictionary, and it uses curly braces which is the same keys as your brackets on an American keyboard, rather than brackets. So my cat, its key is so the key is size, its size is fat, its color is gray, its disposition is loud. So it's a collection of many values. Essentially, it's a list, but you get to make up what the indices are. Okay?
Can you still call them by normal indices?
No, you cannot. You can only use so let me go ahead and play with that over here. So let's go ahead and restart the shell over here. Okay, so let's go ahead and I'm going to drag in this. So my cat, his size is fat, his color is gray, and his disposition is loud. So this sets up key value pairs. Each pair is separated by a comma, and each each pair is see each pair is separated by a comma, and each part of the pair is separated by a colon. So if I talk about my cat now, it just gives me this information back. So if I say my cat, but you access it like you would a list. So if I ask what my cat's size is, so I give it the key size, it will return fat, because we said that the size is fat. If I ask for my cat color, it will say gray. Now this is given a key that you stored, if you ask for the key again, it will give you the value back. So my cat gray, gray was a value stored in there, so it's not going to recognize it at all. Makes sense? It doesn't know what to do with gray, because gray's a value. It's stored in there. So now practically, what are these dictionaries good for? And so it's good for two very versatile things, which is counting things. So counting things, where each key is a thing, and the value is how many times you've seen that thing. And the other thing it's really good for is categorizing, which is saying, given a key, the key is like the category, and the value is all the things that exist in this category. They're also really good for creating essentially classes when you don't want to deal with classes, and creating like coordinate systems when you don't want to deal with lists. So my cat. So you can ask if a key is in there, like is size in my cat? Is that something that defines my cat? Oh, is the string size in my cat? It is. Okay. I don't know why there's an extra new line printing out everywhere, by the way. Maybe it's because I switched the encoding. I'm not sure. So there is, but if I ask for, now let's see if I ask for fat in my cat. False. Even though the size is fat, we're checking, when we do the in statement, we're checking against the keys, right? So, again, what is kind of the use here? Dictionaries you can use, by the way, whatever you want. You can use, right? You can use integer as a key. You don't have to just use a string as a key. So keys are to the indices in a list. Keys in dictionaries are the same as indices in lists. They fulfill the same function. So you can use integers as keys, but you don't have to use any. But you can use whatever you want there. Yep. So, so the big thing about dictionaries you got to know is that they are unordered, right? So the orders for what's it doesn't matter. So here, if I have two, I have two lists: cats, dogs, and moose. Dogs, moose, and cats, right? And in lists, orders matters. If I ask, hey, is this first list equal to the second list? Is spam equal to bacon? They have the same elements, but they're not in the same order, so that's false. Order doesn't matter for dictionaries. So eggs is equal to name Sophie, species cat, age 8. Ham is species cat, age 8, name Sophie. So same key value pairs, right? So we check them. So if we check two dictionaries against each other, if we check two dictionaries against each other and that they've got the same order of stuff, then or a different order, that's fine. They don't actually maintain dictionaries don't actually care about order at all. And because they don't have any order, you can't slice them. If you try to ask for a key that doesn't exist, you get a key error as opposed to an out of range error. So here's one example of something you can do with keys that you can't really, key value pairs that you can't really do with lists. say you're keeping track of people's birthdays. Alice's birthday is April 1st, Bob's is December 12th, Carol's is May 4th. So if you want to get everybody's, so if you want to deal with people's birthdays, you can, so here's actually a pretty cool little program, which I will, which builds kind of a birthday database. And we'll do this before we get back to our examples. So come on. Okay. So while true, print enter a name blank to quit. Name is equal to input. If name is blank, quit. If name is in birthdays, okay, print it out, else. And this again is in your textbook. All right, so this is actually a fairly straightforward program, which shows a pretty cool thing we can do with dictionaries. There we go, sorry. All right, so let's run this. Enter a birthday. So Alice is in there. If I put in Alice, it gives me April 1st because I asked for because what it does, it grabs my input. It asks, hey, is it blank? No, it's not blank. Is the name, is that a key? Is Alice a key in here? It is, so I return the value. I print the value that goes along with the name, and that's the birthday of that person. But if I enter something that's not there, like my name, it says I don't have that. So it asks, what is my birthday? And then it stores it in here. And that's how you do a store operation in a dictionary. You just simply say, this is the key I want to use, and this is the value I want to use. And that's it. You don't have to worry about if the key exists already. This creates the key value pair, right? If I try this again, boom, it's already in there. So blank to quit. So to create a blank dictionary, you just simply do this. D is equal to this blank is equal to these curly braces. And if I want to put anything in it, I can say, hey, my birthday is, I can just simply say like Andrew. It's equal to, and my birthday is April, let's say 5th. Actually, that's wrong. My birthday is April 6th, but this is just also to give an example of what what happens when you use the same key. Well, if you use the same key, it just replaces the value. It overwrites what's already there. So if I put April 6th, it puts it in there. So see how it updated the value. And so dictionaries are basically, they're like lists, except the indices are all made up, and what they are don't matter. So going back to how this helps us for our problem. Well, I mentioned that we're really good at doing that. These are really good at doing two things. Okay. These are really good at doing two things. Counting and counting and categorizing. And here we want to count how many times each word appears in order to find out what is the word with the most, which word has the most, is the most common. Okay? So let's go through, words is equal to line dot split. But before that, let's format this a bit. Let's also convert the line to lowercase. So a line is equal to line dot lowercase. Right? That should work. String has no attribute lowercase. So what is it called? Again, so I go over to the doc to figure out what it's called because that's a common operation. Lowercase. Lower. That returns a copy of the string to lower. So I will now do line dot lower. Right? So now I've turned it all to lowercase, and I've got the words. And so now I need to go through every single word in the line. So that requires a nested for loop. So, but it makes sense here. For each line in our list of lines, and then for each word in the words in that line, right? We can now go through it. We also wanted to get rid of those nasty commas, which we have another command we can do. Word is equal to word.strip, which removes any beginning or ending things that we don't like. So I want to strip out all the commas. I want to, again, this isn't the best way to do it, but I'm doing it anyway like this. Strip out all the periods and stuff.
You use commas to separate all the things that you want to strip out, and then just use one strip.
I'm not sure what we can do with the strip for the separator. I think we might be able to use a regular expression. Let's see. But I don't necessarily want to get into regular expressions too much before we get to that chapter. I only want to introduce so much information all at once. Right? So word.strip here to strip out the commas, and then we'll strip out the periods. All right? And so now we're left with basically a naked lowercase word. Okay? So now we want to see basically, so let dictionary be our, let's create something called a new variable called counts, or not counts, but let's call it word count. Okay, and this will be our dictionary. It's equal to, it's just an empty dictionary there. Okay, so now what we'll do is we'll say for, so now we're going to ask, hey, have I seen this word before? If word is in word count, right? This looks pretty close to English over here. If it's in our word count, have we seen it yet? Then we want to do one thing, which I'll get right back to. It's easier to figure out what you want to do once you have it, if you figure out what you need to do if you don't have it. So if we haven't seen this word yet, right, this word count is going to store how many times we've seen this particular word. Well, if I've not seen it before, that means this is the first time I've seen this word. So word count is equal to, so we'll say word count for this word is equal to 1. Make sense to everybody? And now over here, if word count, if the word's in word count, if we've seen it before, well, that means I've seen it more than once. So let's figure out how many times I've seen it before. Seen is equal to word count of that word, right? How many times I've seen that word. That makes sense to everybody? This is me retrieving how many times I've seen it. Is everybody following so far? Okay. And now I've seen it one more time. So what I'm going to do is I'm going to update the word count by just saying it's now the number of times I've seen it is equal to the number of times I've seen it plus 1. Right? Make sense? Yes.
Couldn't you just do word count word plus equal to 1?
I don't know. There are probably so, but I'm not. But I also wanted to split it up into 2 lines. There's another way to do it in one line. I can do it in one line like this, which is word count. Word is equal to word count word plus 1, but it's kind of confusing that way, and I prefer to, when I'm explaining something, I always prefer to put it into 2 lines. Yeah, easier to read, right? It makes it easier to read. So let's go ahead, and so this will run for the first 1,000 lines. What is the most common word? Well, it won't give us the most common word yet, right? But it will give us the word count for all the most common words. So print out our word count. So there, and it just spat it out, right? And it's pretty big. It's actually a pretty big thing over here. Yeah, actually it's pretty big, and it doesn't really like running through it. It's actually spat out a whole lot of text. Can't really go through it over there. All right, so why don't we instead print out, so what if I tried printing it out like one thing at a time? Like maybe instead, what do? I do this. Print, okay, so for, right? So we can do a for loop. So for word in word count. So this allows you to go through, iterate through all the keys. What order is it going to iterate through the keys? Your guess is as good as mine. Nobody knows what order is going to go through. The order won't stay the same, by the way, if you add a new key, because this is the way hash tables work, which is, again, gets into 2168 material, so 2 courses ahead of this one. But that's fine. But the way it's supposed to work is, and the reason for this is that what we're doing is that we're essentially, dictionaries use up a lot of extra space that they don't have to use. And this is all in the sacrifice of making sure dictionaries run super fast, no matter how many keys you stuff into this thing. So for key and word count, we can go ahead and print out word and then word count. Word count, word. And that's now giving us everything and the number of times I've seen it, right? Right, which is a bit long. Okay, so, but the point being is now you can see that it's working, right? So the question is, how do I figure out what the biggest one is? So there is a there is a function we can do. And it gets into nastiness, but we can that gets into another problem, which is very common and already solved for you, which is sort. So you can so sorting is built into Python. But let's just go ahead and run this program, right? Run it, boom, it's done. So I do have word count still, right? If I ask for word count of the, right? And this is what I like about doing it in idle, is that you can start examining it like this. So can I sort word count? No. Sort is not defined. Sort Python. How to sorting. Python lists have a built-in default method to sort them. Sorted. That's the word. Sorted. So, so you can pass in the word count, and it's probably not going to know what to do with it. Oh, it does. It just simply sorted it by, alphabetical order, right? It took the keys and sorted them, right? Because it said, okay, it asked you asked it to do it, and it just kind of threw up its hands and just said, okay, I'm going to try something. Kinda. Oh, it's crashing on me. Wonderful. I'm dealing with a bit too much data on it. That's fun. Okay, that's fine. Let's go ahead and open it up in, I'm going to start opening it up in here. Oh, there we go. All right. So we can do sorted word count. But then if what we can do is we can also provide something called a key, which is asking, okay, given this item, how should we sort it? Let's see if this works. Let's see. Key dot is equal to, let's see, how do we sort a dictionary? I actually have to look this. So I just actually have to look this up because I realize it's probably not going to work the way I want it to. And it's always a hazard when you kind of remember doing something, but can't quite remember how to do it. Key is, let's see, sort a dictionary by value in Python. How do I sort a dictionary by Python? It's not possible to do that, right? There we go. Sorted. There we go. D.get. That's what I need. So the answer is word count dot get. In other words, given the key, get the value. Let's see if that works. Although it was in Python too. And then sorted 0. Let's see what that gives us. Run in Python. Built-in function or method is not subscriptable. Let's see.
What is subscription?
Oh. List of sorted key. Just trying to figure. Sorry, I'm trying to figure out a. Sorry, what's the subscript mean? It means the bracket operation. So let's see. I was hoping for something easy without having to outsort. Yeah, there we go. How to sort keys of a dictionary by their values. mydict.get. Interesting. That says that I can't do that. Oh. Yeah, that's the issue. I printed out the wrong thing. Okay, it was key error 0. Oh, that's right. So we've got our sorted thing, and we probably want to store it somewhere, so we're going to store it in a list. Right, so we sorted something. We should probably store it in a list, which is going to be, let's call it, done, print done, and see what happens. All right, so it prints out, so this is the least common thing in the beginning, and the most common thing comes to the end, which doesn't necessarily actually make sense here. Grr. Because that should have worked, right? Print word count. I apologize for this. This should have worked, but hey, it happens sometimes. So Python. So if we print out just the word count of stuff, right? We've got all the key and values. Oh, okay, it didn't print out everything. That's interesting. Okay, that's fine then. So now the last thing is going to be, so the last item in done should be our most common word. So how do I get the most common, so how should I get the last item in this list? -1. There we go. The. That's not really that surprising, is it? The most common word is the. All right, what about the second most common word? Let's go ahead and print that out. And why don't we go ahead and get a bit of a slice? Let's get the last 10 words. How should you think I should get the last 10 most common words? -10 to, yeah, beginning from -10 all the way to -1. That goes up by 1. So let's go ahead and print that. That, I, thy, thou, in, my, to, of, and. Those are the most common 10 most common words that Shakespeare used in his first. I know they're very uninteresting. What about negative 20 to negative 10? The ones before that. Me when be love. Okay, so he uses love a lot. That's not too inobvious to anybody else. Let's go ahead and grab. Okay, and now that this works for the first 1,000 words, I think we can go ahead and run this on the entire thing. Right, I don't need this anymore. So let's go ahead and now run it on the entire thing. And now it's thinking. So what, and so the most so let's go ahead, and those are the, not the most 10 common, but the next 10 most common words. So if we wanted to get, again, the most common words, which would be negative 10. Oh, actually, I think that'll be the most. Now, actually, that's going to be off by 1 because it should be, this will start at negative 10. Well, yeah. There we go. So there you go. The really, really common words of Shakespeare. The being the most common, and I too of a. So let's go ahead and talk about what this line does. Well, we can't sort. So let's go ahead. So this will involve us talking about sorting stuff. Okay. Now to use sorting, we just use, to sort something, we can just do sorted. How does it do that? How do you actually sort stuff? That's actually an interesting question. That we'll probably get into on Tuesday, because sorting is one of those fantastically useful things, and knowing how to sort things, not just on a computer, but physically as well, because the same strategy you use for sorting can be used here. This sorting, so this tells you what you want to sort, okay? And then this tells you how you want to sort it by. The key equals. So what do we want to sort it by? Well, we want to sort it by the get function of word count. And the get function of word count is this whole thing, the grabbing a value from it. Which simply does, we don't use it like a function. We don't do word count.get because Python wanted to make it very easy to get these things, for you to access these values without having to type out .get every time. So we've got that. So that's how we can deal with grabbing those values. So so what else can we sort? That kind of brings a good question of like, what else can we sort? Let's see. Let's create a new file in here. Preferences, settings, editor size. Let's go with 20. That was 29. That's a bit too big. Let's go. Can I edit the console size as well? Let's see if this works. No. Oh well. So we've got our editor. We've got. Okay, so we've now got our editor a bit more readable. Okay. What else can we sort? So we can sort things that are like strings. So if I type, so for instance, if I type in string s is equal to a whole lot of stuff. S is equal, if I print sorted S, it's just going to know what to do automatically, which is that you want to put this string in alphabetical order. And it's going to produce a list, right? So it produces a list of all the characters in sorted order. Okay. If I throw a list in it, for instance, if I then also throw a list in it, so let's go with list L is equal to, and I give it some numbers. right? You never guess what this is going to do.
Adds them up.
It doesn't add them up. Actually, if I wanted to add them up, we have a function for that. If I wanted to add up all the values in a list, I can use this, print sum of L. And then anything that you can iterate over, it will sum up.
So we could have done that for like product?
Could we have done that? Let's see. No, because it would have just still been strings, so it wouldn't have happened automatically, because you would have had to convert everything into strings. Still.
But doesn't the sum treated as string?
I mean, well, so it depends on. Well, okay, no, you can't just sum up like a number like this, right? And I'm saying you can't also just do string to the number, is what I'm saying, because again, this is a string, right? It's just gonna it's gonna try to.
No, I meant like making it as a list first and then do sum of product.
Ah, well then you'd have to transform it into a list. All right, so sorting is fairly straightforward in here. Sorting is all about putting stuff from a smaller amount into a greater amount. Do people want me to go over how to do that? Like, I could do that now. It's not exactly a hard thing. Okay, so there's like a billion ways to sort things. We're gonna go over probably the most basic way, which is bubble sort. Okay, so how many of you have heard of bubble sort before? Okay, one person, two people. So there's a lot of different sorting methods. Python uses something called tim sort, which is a combination of insertion sort and merge sort, which are two really good sorting methods. But bubble sort's fairly straightforward. Let's go ahead and define a function called bubble sort. And what it will do is that it's going to take in a list. It's not going to return anything. So this is very important to know about when you're dealing with lists. Like, and it's how because I've not really talked about like what happens to variables, you know, and when you change something in a function, what happens to it. If it's a number, and you change it, it's not going to really. It's just a copy of the number. But for lists, you copy the location of the numbers. Of the list. And so any changes that you apply to the list are going to happen here. So the way bubble sort works is fairly straightforward. It compares pairs of numbers. Actually, easiest to go over is selection sort first, but whatever. We'll do bubble sort first because I said we're doing bubble sort.
Like the 3-sort problem that we did.
It's easier. So what we look over is we look at pairs of numbers. So first thing I want to do is I want to deal with just the indices of everything. So so I'm going to go over I'm going to write a single pass of bubble sort to explain this. So for index in range length of L minus 1. So the minus 1 is important because I'm about to do something over here. But this gives you all the indices of the list, right? Except for the last one. Okay. Left is equal to let's call this, we'll just keep calling it L. L dot index. Right is equal to L index plus 1. If left is greater than right, temp is equal to left L index is equal to L index plus 1, L index plus 1 is equal to L index. All right, so this one's, oh, not L index, temp.
Why is that repetitive? Yeah.
Here we go. So this is a single pass of bubble sort, so it's not complete yet. But let's go ahead and I'll talk about what this single pass in bubble sort actually does. Okay, come on. Okay. What the single pass does is, suppose you have a bunch of numbers, right? And they're listed in order. So you've got like 7, 2, 5, 1, 6, right? So I'll bring up the code for you guys to see while I'm explaining this again. So you've got so what we do is that we go through what this algorithm does is this allows us to go pairwise through the elements. So we're going to look at this pair, this pair, this pair, and this pair. Okay? So these two, these two, these two, and these two. So the reason the value of index is 0, 1, 2, 3 as opposed to 0, 1, 2, 3, 4 is that if I let index be 4 in this, right? Hence this is why I have the -1 here. If I don't have that -1, I'll go all the way over here and I'll say the left entry of the pair is at index and the right entry of the pair is at index plus 1, and index plus 1 is out of bounds there. So we don't need that. So we start here. This is the left of the pair. This is the right of the pair. That's right. You can think of it as index plus 1. You can think of as plus 1 as going to the right and -1 as going to the left. Okay. And all this does is ask them, hey, is the left value greater than the right? Are these two things in order in and of themselves? Are those two things in order? If they are not, then we have these 3 lines where I store the left in a temporary value. Okay? Then I take the thing on the right, index plus 1, and store it in index. I store it in the left. And then I take the temporary value and store it on the right. In other words, these 3 lines are what are commonly referred to as a swap operation. Right? And typically and when you swap something, you typically need one extra variable to do the swap. And then we just continue for every other pair. Are these 2 values in order? No, so we swap them. 5 and 7. 7 and 1 are not in order. 7 and 6 are not in order. And so then this for loop ends. Now this is obviously not sorted yet. But the reason this is called bubble sort is because the biggest item in this unsorted list bubbled to the top. Okay? And if we do this again, the next biggest item will bubble to the top, guaranteed. And then we do it again, the next biggest item. So if we do this again, 2, 5, 1. So basically we ask, okay, are 2 and 5 in order? They are, so we go on to the next pair. 5 and 1? No, swap them. And 5. These are in order, these are in order. So guaranteed 2 items now are in order. We happen to have 3 items in order, so that's great. Are these in order? No, swap them. 1, 2. They're in order, they're in order, they're in order. So if we run this exactly as many times as there are pairs, then we're guaranteed for this to work, to be sorted. The reason being is that the worst case scenario is that if I get something like this, 5, 4, 3, 2, 1, right? All that's going to happen in this is that if I do a single pass, 5 gets swapped, 5 gets swapped, 5 gets swapped, 5 gets swapped, and so the end result will be this. And then if I do it again, 4, and then if I do it again, 3, and then I do it again, 2, and then the last item is there, and we get that last item for free. So if we do this for so now if we do this for blank in range len of list minus 1. So if we do this many times, then it'll be guaranteed to work. So I probably inevitably made an error there, but print. So let's say L is equal to 5 set, something unsorted. Okay, print bubble sort. Actually, let's bubble sort L, and then we'll print L. Okay. And now, as you can see on the bottom, it's sorted over here, which is pretty cool. Let's see. So that's pretty nice to be able to deal with that. Controls, editor family. There we go. I think I figured it out. There we go. So everybody sees that that's sorted. So that's one way to sort items. So sorting is just simply the objective of putting anything that you can in order, anything that and Python's and so long as we can use the greater than or less than sign on it, then Python's going to be able to put it in order. So for instance, if I were to give it A Q B X C L, it puts it in order, right? Python's nice like that. It can use greater than and less than to figure out basically. Greater than and less than will compare anything that can be put in order just fine. Yes, I realize that I'm not recording here. Yes.
Yeah, I was gonna ask if you're gonna be recording it or putting it on.
Yeah, I was recording this. I just forgot to switch back. Yes.
Can you sort a mix of integers and strings?
Let's find out. It says you can't because you can't compare strings and integers.
So it doesn't convert one.
Yeah, it doesn't convert one to another.
So what about words?
Words?
Like would it go with alphabetical as well?
Yep. Right? A, B, C, H, L, Q, X. Right? Alphabetical like those. Hello and happy. Just like that. See?
What about a two-letter word that starts with H?
I mean, again, it applies the same alphabetical rules. So if I said ha there, it should go first because the shorter the words get sorted first before stuff without letters after it. It uses the actual rules for putting things in alphabetical order, as you would hope. So you can sort pretty much anything you need to. All right, so that leads me to these exercises, which are actually going to be fairly straightforward. The last thing I want to mention about sorting, which you'll find pretty useful, is let's see. Is what other things we can do with strings. Or sorry, I just want to make a couple more points on things over here. So suppose I have this list, right? L is equal to range, right? Well, we can turn a range into a list if we want a range of numbers really quickly that we want to use again and again. So like if I want 1 to 100, oh sorry, 0 to 100, and I want even numbers like this, that just gives me a range function. So if I say L is equal to if I throw it into a list now, that'll actually get turned into a list of numbers. Okay. Now suppose I want this in reverse. There I can actually do some pretty nifty stuff here. So first off, if I just do this, so first let me talk about aliasing here. L2 is equal to L, right? These two guys are the same list. And I mean, not just because they came up with the same thing, but if I change that first item to negative 100, right? That's, everybody just remember that's how you change items in the list, right? If I print out L and I print out L2, they both change the same list. Now the reason is that what gets stored in L, right? When I say like something like x is equal to 5, I've been saying 5 is what gets stored in X, right? What gets stored in L isn't the actual list. It's the memory location of where you're going to find that list. In other words, where that computer stores it in memory, and then it just looks it up for you automatically. So the end result is if I make a change over here and over here, it's the same changes. Now let's assume for a second that I want actually to make a copy of the list. I want to have L1 and L2 be two lists that have the same values, but they're actually different lists. Well, I can make a copy by creating a slice, an empty slice like that, right? If you remember, leaving this blank means from the first item, and leaving this part blank means to the last item. And so now if I change this, L2 0 is back to 0. Right now they're completely different lists. So that's a nice thing you can do with slices. You can also completely reverse a list with a slice as well. Now remember, or you can create a reversed copy of it. Remember, this means from the first item to the last item, right? And so you have three arguments: first item, last item, and then the last one means the order you want to go in. So the default is 1, but if I put -1 here, it'll give it to me in reverse order, which is pretty cool. So you can reverse a list pretty simply like that. Works for strings as well, right? S is equal to hello, S is equal to, and now if I say S : -1, hola. So you can reverse strings like that. Oh yeah. So that's a pretty nifty trick right there. So all right. So there isn't much time left in this class, but I'll let you guys work for that amount of time. So what we're gonna do is that I put up 2 turtle assignments, essentially 2 small turtle assignments online. And then I'm going to throw a homework online that deals with some basic array exercises. And once we are able to do that, when we get back on Tuesday, we'll be doing a paired project that will work with files. So in other words, you'll want to work with someone else. And we'll be doing a basic investigation on how we can detect fraud, which seems pretty relevant for anybody who's kind of working in any kind of setting that you're dealing with a lot of documents. So, all right. And